Hi guys, it's Mrs. Tellas. I'm going to cover 5.7, which is graphing systems of inequalities on a coordinate plane. So it also is like, is it a solution? Um, yes or no, from a picture and from a point. And then we'll be graphing a single inequality and then graphing both inequalities. So here we go. So if we start here, we're going to determine if 0, 0 is a solution to this system. And we're going to do that by graphing the point that it's asking. So if I go over here and I graph 0, 0, it's right here in the center of the graph. So as I look at this, their solution set would be what's in this dark shaded area. So these are all the solutions in here, not included the dotted lines, but everything else that's in here. You can see that 0, 0 is not in that area. And I know that that's the area because it's the double shading. That's where it's extra dark. So no, it is not. And then if I do these, so 1, 2, so right 1, up 2, that's a no. 3, 8 is right 3 and up 8. So that's definitely a yes. That's in my dark shading up here. And then -5, 1, 2, 3, 4, 5, and all the way down to -9, that's also a no. So anything again in this shading up here is part of the solution. And since these lines are dashed, not on the lines, but anything inside these two lines. So if you remember, this one is less than, and this one is greater than, and greater than equal to, and then the last one is less than or equal to. So just reminding you what those look like. And down here, it asks you to create a dash line. So remember, our dash lines look like that. You can also do it with dots. And a solid line is just a normal line. And lines have arrows on the end because they go on for forever. So that's what we're going to be considering. Remember, a dash line, we use a dash line when we have greater than or less than, and we use a solid line when we have greater than equal to or less than equal to. So those are all things we have to remember from 5.6, just graphing single inequalities. So here's a simple inequality or a single inequality that I'm going to stick on the graph. So I'll go through the process. So if I use y equals mx plus b, my slope-intercept form, I can tell very clearly that my b is 4 and my slope is -1/5. So when I go to graph this, I'm going to go to +4 on the y-axis, 1, 2, 3, 4. And then since it is a -1/5, I'm going down 1 and right 5. So down 1, 1, 2, 3, 4, 5. Again, down 1, right 5. I can also go up 1 and left 5. And up 1 and left 5. And what the line is I'm trying to create, I'm trying to split the graph in half into two planes. So once I get the line all the way across the graph, I can draw the line. Well, is it solid or is it dashed or is it solid? Well, I know that this is a dashed line because of this symbol right here is greater than. So it's a dashed line. So here I'm just going to stick some dashes in here. So I've got a little points and a little dashes, but I notice how it separates. I've got the top above the line and I've got below the line. So it separates it into two planes, two half planes. So now for my shading. So my shading, I always use the origin if I can. So is 0, 0 true or false? Well, let's see. So I'm going to test 0, 0. Right now I have no idea. It is a test to see if 0, 0 is true or false. So I plug it back into my original inequality. So n for y, I'm going to put 0 is greater than. -1/5 times 0 is 0. So that just zeroes out. And then the 4 just drops down. And I see if it's true or false. So 0 is greater than 4. Well, that is false. 0 is not greater than 4. 0 is smaller than 4. So this test point that I decided here is on the false side of the line. So the true side would be the other side. And I always shade the true side. There's never a case where I shade the false side. So is 1, 1 a solution? Well, we can take a look. So right 1 and up 1 is on the false side of the line or on the false plane, the false half plane. So no, it is not. Okay. Questions on this? All right. All right, so if we write the inequality going the other direction, this is review as well. So my b's right here, -2, and my slope is up 1, right 1, up 1, right 1. So my slope is 1 over 1 or just 1. This is a dashed line, so what I know from that is it's either greater than or less than. And 0, 0 is right here in the center of the graph. So that is on the true side, and I know this is the true side because the shading is over here on this half plane. So I know I want to make a true statement with 0, 0 using my inequality that I'm about to write. So I'm going to put y, leave a space for the inequality, then 1x minus 2. And this 1 here is optional. It's there whether we write it or not. And then I plug in 0, 0 for x and y. So when I put y in here, it's 0. And when I put 0 in here for y, it's 0. When I put 0 in for x, it's also 0. So I want to make a true statement using these two numbers. Well, 0 is bigger than -2. So since it's bigger, I know that the symbol will be like this. And I also know that there's no equal to because I decided it was dashed up here. So this is my inequality for this line. All right. Okay, determine whether the ordered pair is a solution of the given system. All right, what it's asking is if we graphed these two lines on the same graph, would this point right here be in the double shading? Yes or no? And I can tell because if I plug them in and they both give me true statements, then yes, it would be. If either one of them are false, then it doesn't. So let's see, x is going to be -2 and y is going to be 3. And I'm going to plug them in. So in for y, I put 3 and in for x, -2. So on the right side, I've got nothing but numbers. I'm just going to type them in and that's -8. 3 is greater than -8. This is true. So far, I've got one yes. In order to be a yes, that's in the solution set, it has to be a double yes. So let's plug over here as well. So I'm putting in 3 for y and -2 for x. So this is 6 plus 2 is less than or equal to 6. So this one's false. 8 is not less than or equal to 6. So since one of them came out to be a no, that's not in the double shading. So that's how you do that. So if you want to press pause and give one of these a try, actually, let's do the first one. Okay, so 3, 1 is what we're testing. And we want to see if x is greater than or y is greater than x minus 4 if it's a part of the solution. And also this one if it's a part of the solution. And remember, it has to be part of the solution for both of them. So you have to get a yes for both. This -4 goes over here. All right, so on this particular set that or this ordered pair we've got x is 3, we've got y is 1. So we're going to plug them in and see if they're true. So let's start with this one. So x is 3 and y is 1. So 1 is greater than -1. That one's true. That one's a yes. 1 is bigger than -1. And if I plug this one over here, so x would be 3 plus 2 times 1. So that's 5 is less than 5. Well, that's false. So that's a no. So this is a no overall. So I can tell from the yes and the no's that it'd be part of the shading, but not part of the double shading. So that's why I'm not including it as a yes. They both have to be yes for it to be a part of the solution. All right, so if I do my first graphing one, and this is really what your assignment is over. There's a couple of those other ones. Is it a solution? Is it in the solution by plugging or is it in the solution by graphing? But this is the main skill right here. So if I go through and graph each of them separately, just like I did on the connection to prior learning, what I'm looking for is the double shading. That's where the solution truly is to the system. So if we work through this first one, my slope is 2 over 1 and my b is -1. So -1 is down 1, up 2, right 1, up 2, right 1. And I can also go down 2, left 1, down 2, left 1. And again, I want to go all the way across the graph. I want the graph to be broken into two half planes. It is a solid line because it's got this equal to right here. So I know that I'm going to connect and make a solid line. All right, is 0, 0 true or false? Well, we have to figure it out. So 0, 0 is on the left side of the graph. It's my test point. So if I plug 0, 0 into my inequality, this would be 0 is greater than or equal to -1. That is true. 0 is bigger. So the test point is on the true side of the line. So if that's the case, I would shade over here on this side, all the way down. Now I don't want to get my shading too dark because I got to be able to graph the other line. So we'll change colors and we'll graph the other one. We're going to do the exact same steps on the same graph. And let's get rid of this point and this true. So we just have shading. All right, so right here, my slope is -1 over 1, or just -1, and my b is 2. It is a dashed line because there's no equal to. So let's go over and put it on the graph. So b is 2, down one, right one, down one, right one. I'm going to go all the way across the graph because, again, I want to break the graph into two half planes. So instead of going down and right, I can also go up and left, and we decided it was dashed. So I'll just stick some dashes in here in between the dots or the points. And then we have to figure out the shading. So on the green one, the shading or the origin is down here. It's below the line or to the left, depending on how you're looking at it. So let's plug 0, 0 in. So 0 is less than 2. That's also true. 0 is less than 2. So this side, this origin is also the shaded side for the green one. So I'm going to shade all of the green one, including this part over here. And you can see that there's a double shading here. You can see that there is a double shading. Here's my extra shading where the blue and the green are both currently at. So I can even highlight it so you can see it a little better. So this way, not including what's on that line. And then, yes, this line is included because it's solid. So anything over here in this little shape I've got here, 1, 2, 3, 4, 5, like pentagon, irregular pentagon shape, is part of the solution. If it just has blue shading or it just has green shading or there's no shading, that's not part of the solution. So anything in here would be a yes. All right, let's try another one. Actually, I want you to pause the computer and you try this one. And then I'll go back and do it again and we can compare our answers and see if they're the same. So number 3 says solve the systems of inequalities. So if I work through it just like I would if I was working on a piece of paper, my slope is 1 over 1 and my b is -2. It is a solid line because it's got this equal to right here. So I can go ahead and stick this on the graph. So -2 and then up and right, up and right, up and right. I'm going to go all the way across. And I want to go all the way across on the other side too. Okay, again, my point is to cut the graph into two half planes, and I've done that. And it's a solid line, so let's connect them. Try to make a straight line. There we go. All right, now let's test the origin. The origin's above it or to the left of it, depending on how you're looking at it. So 0 is less than or equal to -2. Actually, it says 0 is greater than or equal to -2. That's true. So I'm going to shade this side of the graph. So all of this side over here, because the origin is the true side of this graph, because I got true when I did that. All right, so now let's do the other one. We'll change colors. Okay, so slope is 1/3 and b is -2. So same b. And I'm going up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3. It is a dashed line because there's no equal to. So I'm just going to dash it up a little bit. And then 0, 0 is above this red line. So I'm going to plug it in. So 0 is less than -2. That's also false. So above it right here, this is the false side. So that means the true side is down here. So I shade the true side. And you can see that they overlap and they're shading down here in this area. So this one would include the line and the dot part would not include the line. Whoops, that went up too high. I shouldn't be up here. There we go. That's better. So it's this little area right here that's included in the double shading. All right, let's do this one. Solve the system of inequalities. And this one is a horizontal line. I know that because I could make myself a little table. So if this were an equation, it would say y equals 3 or y is always 3. So on the y's, I would put 3, 3, 3. And then I'd pick friendly numbers for the x like 1, 2, and 3. And then I could graph these points. So 1, 3, 2, 3, and 3, 3. So this is a flat line at y equals 3. It is a dashed line as well because there's no equal. So I'm going to dash all the way across. And then I'm going to test the origin. The origin is below it. So 0 is less than 3. That's true. So this is the true side where the origin is. So I'm going to shade under the line down here. Excuse me. There we go. All right, now let's do the other one. We'll switch to blue. All right, so here my b is -4 and my slope is -2/1. So I'm going to go down 4, 1, 2, 3, 4. And then I can go down to right 1, which takes me off the graph, or I can go up to left 1. And I want the graph to be cut in half. So I'm going to go all the way across until I can't go anymore. This is a dashed line as well. So I'm going to dash it up a little bit, stick some dashes in there between my points, but definitely not solid. And then I'm going to test the origin again. And it's dashed because there's no equal to. So if I test the origin's right here to the right of this line. So 0 is greater than -4. That's true. 0 is greater than -4. I put 0 in here. I dropped here. This canceled out. The -4 dropped, and it's true. So I shade the right side where the origin is. And I shade all the way down. And you can see where the solution is because there's double shading on the right side of the line. It's over here in this general area. Okay, where it's just blue or it's just red or no shading, that's not part of the solution. But where I've got the double shading is part of the solution. All right, so I'm all finished. I hope you understand. If you don't, please email or let me know. We're getting ready to do a worksheet. So thanks. Take care.